Hi friends, all of you welcome to Suneel Engineering Academy. Students, in this basic electronics through topic wise MCQ series, we have completed 3 sessions. It is the fourth one. If you want previous, click on the playlist, you can find out the previous session. Let me check up to which we have completed in the previous. So all these questions completed now. If you want to download the PDF, you can visit suneelengineeringacademy.com. Up to this one we have completed. So coming to the first question in this session, the capacitance present in reverse bias. The capacitance present in forward bias and also reverse bias. Okay, so if you can consider a PN junction, one side is doped with P, one side is doped with N. Between that, a depletion layer forms. Okay, that means it is positively charged and negatively charged. So between the two charged plates, one dielectric is there, then capacitance is formed now. Whenever you apply the forward bias, what is happening? The depletion layer width decreases. That means C is equal to epsilon A by D. The distance between those is decreases. Then capacitance will be more. And in the same way, whenever in the reverse bias, what is happening? Depletion layer size will be increases. So capacitance will be decreases. Okay. So the capacitance present in reverse bias is considered as transition capacitance. You can also say that it is the CT. The capacitance which is present in the forward bias is nothing but diffusion capacitance or storage capacitance. Diffusion capacitance or storage capacitance. In the forward bias, the distance between those is less, so capacitance is more. Okay, here distance between those two is higher, the capacitance is less. Okay, the capacitance is less. So here you can say CD is double greater than the CT. This is a very important one, guys. Nearly 5,000 times. Nearly 5,000 times. Okay, and the CT depends upon the voltage, the reverse bias voltage. Whole power n, or if you also consider the new voltage V reverse bias plus Vk whole power n. Okay, so this n value is equal to 1 by 2 or 1 by 3. If you can consider Weyeractor diode is based upon this transition capacitance only. For that, n value is equal to 1 by 3. These are the very important questions in the two capacitances. Okay, so here the capacitance present in both forward bias and reverse bias. In case of forward bias, D for D, diffusion capacitance or storage capacitance. In reverse bias, that is transition capacitance is formed. Based upon this transition capacitance, the Weyeractor diode is works. Okay, so here reverse bias, transition capacitance, and the CD, that is diffusion capacitance, is very higher than the CD. Coming to the next one, a PN junction diode act as dash. We know PN junction diode amplifier? No. It can be act as rectifier. Yes, it can convert AC to DC. Okay, and it may be also insulator whenever it will be act in case of reverse bias, but they have not specified like that. So the best application is rectifier. So can give the answer as option B. Okay. Gold is often diffused in silicon PN junction devices to dash. Why gold is diffused? Gold is the metal and it has very high positive temperature coefficient of resistance. So that means as temperature increases, the resistance also increases, then recombination rate, I mean conductivity decreases. I mean conductivity decreases. So to reduce the recombination rate, we use the gold. Okay. Coming to the next question. PN junction diode dynamic conductance is proportional to dash. We know the conductance. Conductance is equal to current by voltage. Correct? That is nothing but we can say current by voltage. Resistance is equal to voltage by current, in the sense conductance is equal to current by voltage. That means conductance is directly proportional to its current. Conductance is directly proportional to its current. Okay. So Gm is directly proportional to the current. Okay. So answer is option C. AC resistance of forward bias PN junction diode operating at base voltage V and carrying I is dash. The AC resistance is equal to change in forward voltage by change in current. So the answer is option D. Change in voltage by change in current. Okay. And coming to the next one, the diffusion capacitance of PN junction diode. Diffusion capacitance of the PN junction diode. The CD is generally proportional to e power V by zeta Vd. That is, it is exponentially increases with the forward bias voltage V. Exponentially increases with the forward bias voltage V. Coming to the next question. The depletion region of semiconductor PN junction diode has dash. Given depletion region contains immobile ions, immobile positive and negative ions on either side. So the answer is option B. Coming to the next question. Which of the following statement is correct under small signal operation? First of all, if you can consider AC resistance is equal to sum of bulk resistance plus junction resistance, guys. This bulk resistance is nothing but the forward voltage minus Vk by the forward current, and junction resistance is depends upon that is a fixed value of the voltage by the forward current in milliamps. For this is 25 for germanium. In case of silicon, that is 50 millivolt. Okay, that means here the voltage is constant. It does not depend upon any forward voltage. Okay, so just inversely proportional to forward current. So for small signal operation, as IF is small, for small signal operation, IF is small means RJ is more. So RJ dominates bulk resistance. Then RAC is approximately equal to RJ only. So here it's junction resistance predominates. Junction resistance predominates for small signal operation. For large signal, if IF is large, in case of large signal operation, IF is more, RJ is less. RJ is very less than RB. Then RAC is almost equal to RB. Then bulk resistance predominates. Bulk resistance dominates. Okay, all of you clear? So always consider with respect to RJ. Why? Because here voltage is almost constant. Only it will be with respect to the field current. But here forward voltage is also there. So we consider this one. So junction resistance is predominates whenever small signal operation. Coming to the next question. Junction capacitance of PN junction depends on dash. Junction capacitance will be depends upon both applied voltage and also concentration, doping concentration. Okay, both applied voltage and also doping concentration. Why? Because I have already given the capacitance is equal to 1 by V plus Vk whole power n. This Vk depends upon doping concentration, Q n donor Wn by. So that means it depends upon doping concentration and also the applied voltage. Coming to the next question, what is the typical value of the rate of current in PN junction diode in the forward bias and that in the reverse bias? We know very well in the forward bias, the current flowing is generally in milliamps. In reverse bias, the current flowing is nothing but leakage current, that is nothing but in order of microamps or nanoamps. So the ratio they are asking milliamps to microamps 10 power minus 3 by 10 power minus 6, that is 10 power 3 order. So the ratio will be in 1000 times, that is 1000 order. So the answer is option D. Okay, answer is option D. Coming to the next question, guys. In the following, which diode is generally operated in breakdown region? Which diode is operated generally in breakdown region? That is Zener diode. Why? Because in the breakdown region, it can be act as the regulator. It can be act as the voltage regulator. Okay, so that's why it is generally operated in reverse bias breakdown region. Okay, reverse bias breakdown region. Coming to the next one, which is act as a voltage regulator. Just now we have discussed, that is Zener diode act as a voltage regulator. Okay, all these questions belongs to special diodes. These are also very important, guys. Zener breakdown occurs when the reverse voltage is dashed. Here we have two types of the breakdowns. One is Zener breakdown and the second one is avalanche breakdown. Avalanche breakdown. Zener breakdown generally happens in case of heavily doped regions. This is happens in case of lightly doped. Very important points. Simply you can remember Zener diode is the heavily doped diode. So Zener breakdown occurs in case of heavily doped. Avalanche breakdown opposite, lightly doped. Okay, so whenever the doping is more, if you doped more, then what about the depletion region? Less na. Depletion region less. That is, you can say narrow. Okay, here lightly doped means wide depletion region. Wide depletion region. So whenever there is a narrow depletion region, the depletion region is narrow here, very less. Then what about the requirement of voltage to break that? A very less voltage is also enough. So whenever the voltage is less than 6 volt also, it can break the junction. Okay, so but here if it is a wide depletion region, then we have to apply more voltage. So it happens whenever the voltage is greater than 6 volt. Okay, so Zener breakdown occurs less than 6 volt, avalanche breakdown occurs greater than 6 volt. Okay, it is due to rupture of covalent bonds. It is due to collision of atoms. Whenever the voltage is high, then collision of atoms takes place. So due to that collision atoms, the junction will be breaks. Okay, the junction will be breaks. So once again, guys, a simple idea: Zener breakdown. Zener is nothing but heavily doped. So it may be occurs in case of heavily doped regions. Heavily doped, whenever the doping is higher, depletion layer size is less. Okay, so that is narrow depletion regions. So whenever the depletion region is narrow, a less voltage is also enough to break the junction. Okay, that is less than 6 volt Zener breakdown. And here avalanche breakdown more than 6 volt. Why? Because it is a wide depletion layer. To break that, we require a lot of voltage. Okay, coming to the next question. Zener breakdown occurs due to dash. Just now I have given Zener breakdown occurs due to break or rupture of covalent bonds. Break or rupture of covalent bonds. Collision of atoms. This is avalanche breakdown. Zener breakdown occurs mainly in dash depletion regions. Heavily doped na. Heavily doped. Heavily doped means narrow depletion. So narrow. So the answer is option B. Avalanche breakdown occurs due to dash. Due to collision of valence electrons. I have already given. And avalanche breakdown lightly doped case. Correct? Lightly doped. Lightly doped in the sense depletion region, wide depletion regions. I think all of you clear. So many students just by heart these questions na. So no, not required if we understand in a simple way. Okay. And coming to the next question. In the following, which is used to remove unwanted ripples? The device which is used to remove unwanted ripples, that is filter. That is nothing but filter. Okay. So here there is no filter is there. So we have to select none of the. We have to select the none of the. Okay. Okay, students, we will discuss the remaining questions in the next session. Okay, so if you have not subscribed this channel, please click up subscribe button and also share the videos to all your friends. Okay, due to your encouragement only, I can take more sessions. Okay, so all of you try to support for more sessions. Okay, thank you guys.